Alright, moving forward, we'll be applying our doors and windows. So for this project, we'll still be making reference to our material here, because we're designing a 2-bedroom bungalow, so the material is here. We are having a 900mm window at all ends of the living room. At the west area of the living room, then the south area of the living room, 900mm window. Then for the dining, you have a 15mm window rather. So let's go to our ground floor level. Then let's check if you have something loaded in already. So if you go to your window, you would see, okay, I have this loaded in already. But usually you won't see something like this here. If you want to get your windows, you can just always come to architecture, come to your windows, components, then modify place, choose components. Then for your window components, at the moment it's set to be at my Revit city in my desktop, but yours will be saved on the default place. All your windows should be in Revit. So moving forward, we'll be applying windows to this particular project. So I'll just go to where I have my Revit city on my desktop and choose from there. So this is my Revit city. Then I would go to look for windows. Alright, so just like before, we have an aluminum exterior window which looks good because this could serve for our 900mm window. Then I think we have a fixed window already loaded in. I think we are good to go. Yeah, I think we're good to go. So I like this DBL casement window, so let's just use it to create a variety of windows for the house. So let's choose this also. Alright, so let's apply this 900mm window here. So let's use this aluminum window. Already saved this. I already saved the 900mm window here. But if it's not saved on your project, you just come to edit type, then duplicate this and change the name to, let's duplicate, for example, let's change this to 900mm by 12mm. Then 1mm window. I think this is good. Alright, so what we'll be doing now is we'll be changing the dimensions. We have the rough width to be about 1800, so let's change this to 900 for the rough width. Then the height of the window should be about 1.2. So we have the seal height, the default seal height. So let me explain what the seal height is. So if you press OK, let's load this window in. Yes, right, this should be about 900mm. So if you go to your west elevation where this particular window is, let's place this also here. Okay, if you go to your west elevation where this particular window is, you will notice something. Just like when you're doing your plan, a bungalow for your normal drafting drawings, you would see something like this. Let me use this for instance. You see something like this. You have your level ground here where your building is sitting. You have your DPC level to be about 450 or 600. For our project is about 450. Then we have our head height somewhere here to be 3 meters. So from here is 3 meters. Then from here to here should be about 3 meters, obviously. Then we have our 450 here. For the seal height of this particular project is calculating from here down to this place, and the seal height is about 1,300 or 1,000 something. So we need the C height to be about 900, because from here to here should be about 900, and we have 1, 2 window, then we have another 900 from the head height of the building itself. So the C height, let's make it 900. That's what the C height is. So if you click on this window, you see the C height to be about 1016. So let us change this to 900. Alright, so at the moment the window has changed, but you don't have to always change all of them. You can just align this window to this level. How do you do that? You go to your modify panel and choose your align to. For your align to, press AL on your keyboard, AL, then you align this to this, so it will drop down. You can also lock this, so that if you, in case you change this later on, let's say we change this from 900 to 300, the both of them would move together. So that's one of the advantages of locking a particular thing. So let's go to our ground floor level. So I have my material with me at the moment, so in case I'm not popping up this particular page for you to see, now I'm using a hard copy material already. So for the dining area, we have our dining to have a 1500mm window, the same window. So but we don't really have a 1500mm window loaded in, so let's just choose one of them, then duplicate this. So let's duplicate this particular one, duplicate, then let's change this to 15mm by 12, which is the height of the window. Let's just say height, then let's just call this width. Okay, that's the height and this is the width. So let's change the rough width to 515, and let's change the rough height to about 1200. Okay, this is looking okay. Okay, let's apply our window here. Then for the kitchen area, we have a 1-2 window here. Let's duplicate this further. Duplicate, and let's change this to, for the width, 1-2, and the height remains constant. So for the width, let's change this to 1200. Alright, so this is looking good. So the default C height is set to be 160. Let's change it to 900. 900, okay. Then we are applying the window here, somewhere here. Okay, so for here we have a 900mm window, I think. So let's choose a 900mm window. Apply here. Then for the laundry area, I believe it should be 1200. Okay, then for the bedroom, okay, I think the bedroom will look nicer with a DBL window. So let's use the DBL casement window and edit the length to be about 1 to edit, then let's duplicate this. Why do we duplicate assets in Revit? Rename this to 1200mm. For the width, then let's say 1200 for the height. Okay, the reason why we duplicate assets in Revit is so that with the changes you make to this particular asset won't affect. If for example I've loaded this particular window previously in a particular place in that project and I don't duplicate it, if I don't duplicate that asset, something will happen. What will happen if I make changes to this particular window, thinking I'm trying to create a new kind of window without duplicating this one, I will change the properties of this window that are applied to other places in the same project. So that's one of the reasons we have to duplicate in Revit. So for the east part of the bedroom, we have another 1 2 here. Then for the master's bedroom, we have a 1 2, and we have 750 window on both ends. So I think what would work best for that kind of window, which is in 750, you can't use a sliding window. It won't look nice. So let's go to our windows, then let's load family again. So let's look for something like a double hung window. Let's look for a double hung window. For the master's bedroom, this would fit perfectly for a 750. So we have a 750mm window for the master's bedroom in front here. So let's apply that window. Okay, so escape. Okay, let's change. It's not in 750. Sorry. It doesn't matter. Let's just change when you change this without duplicating, it will change the property of these two windows itself. So let's just rename this to 750mm window. Okay, so if you are good, we just change the height to 200. So let's change the default width. Then the width should be about 750. Okay, so the C height looks correct, but it's supposed to be 900. So let's change this to 900. Okay. So yes, we are good to go. So now these two property has matched. So we have another window here where the WCs are. So I would preferably go with this same type of window, but for the master's bedroom we're editing it to 600 instead of 750. So let's just edit this, duplicate, then change this to 600. Then press OK. Okay, so for the height, same as 1 2. We're talking about a tallest window, so we can't have it to be about 1 2. Let's just change this to be about so best practice. Let's just change it down 900. Now that seems okay. I'll use 600, but I don't really like a very small window that much for. Let's use 600. There's also a fixed window. You can actually use since we're using 600, let's not use this double hung window. Let's just use a fixed window. So there's a fixed window here. Let's just pick one and duplicate. Then there's 600mm. Okay, it's okay like this. Then for this height, yes, the height should be 600 and the default with 600 also. The seal height should be 900 plus 300. The seal height should be 1 2. Okay, so let's change this to 1 2. How do we get 1 2? Since the C height for the normal window of 1200 is 900, So if you are cutting 300 out of it, or let's say you are measuring from the head height of the building, let's say you are measuring from this place to be 1.2 meter, sorry, 900 millimeters, sorry, 0.9 meter. Then this window is 600, 0.9 millimeter plus 600, that's about 1,500. So that was a mistake. I want to. The sea heights. Let's go up to our west elevation. The sea height for this particular window should, yes, it's correct. Then if it's going up, the sea height would be about, I think this is 1.2, and the sea height would be around 1.5, not 1.2, sorry. Okay, so for this particular window, for this case window, for this part, let's go to architecture of the windows. Then let's just grab simply, if we increase, let's say that particular window, so let's just choose one again. Okay, let's just choose one again. Let this duplicate 600 millimeter. 600 millimeter. Change the height to be 600. Then the width to be 600. Then if we have from here to here for a 1.5 window to be 900 or 0.9 for the seal height. Then if we have a 600 millimeter window here, the seal height becomes 1.5. From here down to this place becomes 1.5. So for the seal height for this particular project will be 1.5. So let's change the default seal height to be 1,500. Then press OK. So if we check this particular window, put it here. The window is there actually, well, it's not showing this view for some reasons. It's not showing this view. Adding our doors for this particular project. So add our doors. Just basic. You have a simple flush door here. I think this should serve for the internal wall. But if you more aesthetically pleasing door, go for the external, for the entrance door, go and do it from the project. So let's just use this one. So this particular door is about the properties of this door. Let's edit this. The width of the door is 915. Let's just change it to 900. No need to duplicate, but we are not, because we are not using this aspect. Let's just rename this to 900 millimeter door. Sorry, door. Then press OK. let's change the width to 900, and the height should be 2100. Okay, this is looking good. So you can just change the properties of the frame and the panels. So let's just, when we apply materials, that would be doing. So let's apply the doors all over the place. This the door. So we have it and door opening is cutting through this wall, which is not looking right. So I don't think this door is 900 millimeter. This door can be 900 millimeter. So let's just use this, probably a 750 door here. Let's use 750 door because this door So I'm showing you how to copy dimensions from levels to levels. So we have our dimensions given here at the moment, but I want the dimension to be on ground floor because I'm making reference to this dimension on my ground floor level. So let's unhide this one. Let's do something. Let's copy this to ground floor because our ground floor level doesn't have dimensions in it. If you look at it, it's not with the dimension. There's no hidden dimension over here. The easiest way to apply dimensions on our natural ground level. So let's do this. Select this, then select all instances visible in view, then copy. Then you see your modify panel. Modify panel, just go to where you have this brush. You see your copy to clipboard. So copy, then you see paste. Where do you want to paste it? Align to selected view. Just align it to our ground floor view. So if you copy all these dimensions we have in our natural ground level to our ground level. So when you go to your ground level, you see those dimensions now. So you can apply to it now. You see it's all them have dimensions now, so you don't have to redraw all the dimensions again. So when we are done with it, to hide this dimension. So what we are having here now is we have some discrepancies. We're trying to clarify. So we have one file here which is 1550, which is actually correct. So the discrepancies we have in okay, so this particular wall is correct also. Okay, I see what the problem is. The problem is this particular project wasn't done with a 225mm wall. It was done with a 150mm wall. That's why if you look at this project, the doors are almost cutting through this wall. So the reason why we have a significant cut on this particular wall is because this wall is 225mm wall. So the thickness of this wall you're having here and the thickness of this wall you're having from here is where the door is supposed to be. So let's just change the dimension of the door to something smaller. Let's edit type. Let's change this to something like 800mm door. So let's start with 800. For the width, see the align this to this. So see how small gap we're going to see. Can work with this. So let's do something in our working process. Let's move this down to this place. For here, let's split this. SL to split. Let's split this. Then you can let's move this for the bits. Alright, so also use your align dimension just to bring this wall to this wall. So this walls are too close to each other. Okay. Okay. So I'll use your align dimension this way. And touch this to align these two walls together. If there's something you like, you can lock the dimensions. So whenever you move this, that one will move. So we don't want to move this, let's move this way. Then just anchor this to this space. Alright, so the next thing we're doing is we would be creating our doors for our WC. So the doors for this WC should be about 750. It's not giving me a dimension, but this is 750. So let's create a 750 door. Go to architecture, go to door, then let's duplicate this. To duplicate this, then change it to 750 mm door. 750 mm door. So let's change the width of this to be 750. Alright, so let's place those doors on the area. Alright, so this is good here. Let's flip this door because we want the door to actually rest on the wall. So let's press space bar. Flip the door. Alright, so let's place the doors on here. Okay, so I think we're looking fairly good at the moment. So we have a door at our store area. We have a door at our store area. So this store area, I would strongly advise to using the 750 mm door here. So let's just keep the door here. So let's use a 900 door. Sorry, let's use a 900 mm door. Okay, so we have a door here. Let's just right click. Then we have another door here. Now let's move this. Alright, so next we're doing is to apply. There's a door so right here at the laundry area. So let's apply that door. So the next thing we're doing is to just cut this dining area. We have this place here. There should be an opening there. Alright, so what we can do is let's just split and do it SL. Then just split it here. Then close this one. Okay, so successfully done the internal. Okay, we have another door somewhere behind the house. So let's use this. Let's change the properties of the door down. So this here. So for the porch, we'll be using a double swing doors. So let's go to the door. You go to down, you don't see your load components here. There's still a way I do this thing. I don't prefer loading from the load family on Revit. I prefer sometimes opening the Revit City or Xavier. I have my components out. Just come here. So we are checking for a double door. So let's go to door. Then go to doors. I'll just come here and drag and drop it somewhere here. So that's how I try to do this. So we have exterior doors here. Let's choose some exterior doors. Let's use this nice. Let's go drag and drop here. So it will create that door for you. That was one door. What's happening is this. It's trying to convert. Apply first. Let's apply here. Okay. The door looks very big, so let's change this door to 1200. So for the width of the door, let's just change it to 1200. It's 2100, so 2100. Alright, so we apply this first. Okay, so I think that's it for about now. Then for this, let's apply our work in closets. Remember, you don't have to overmodel, you don't have to go and look for a wardrobe or a model from Revit City or anywhere to come and drop here. We are doing a floor plan, so let's just use a detail line to apply our wardrobe here. So when you go to annotate, you have detail lines. Collection in line styles here. So let's just create our outline for this. The working closure should be about 600 meter deep, so let's change this to 600. This is 500, so let's change to 600. 600, so then detail lines. I'm trying to create our wardrobe. Go on this, copy this, copy this, and copy this. Yeah, let's mirror it to this other side. So just use draw mirror abuse, or else just pick. So we can pick the center of this then to mirror the wardrobe to this other side. So I think we are good to go at the moment. So since we have a beam running here, let's indicate that beam detail line. Go to detail line, let's change the line style to demolished. So let's create something that looks like a beam line here, then another beam line here. So okay, we have a door somewhere here. Let's also apply a door somewhere here. So let's apply the door. Alright, so I think that's it for now. You might be wondering how this floor pattern came about. How are there different patterns on this floor? Yes, all these are different floors. This is one type of floor, this is another type of floor, this is another type of floor. But this is not the rendered view. These are not materials added for rendered work. It's just a graphical, it's just a way of making the floor plan look more presentable graphically. So on the appearance view, you can also add materials on the appearance view. Both views are different, both appearance view and graphical view are different things. What's an appearance view? An appearance view is an appearance view is the kind of view you use to show your rendered work, or the view you see before you render your work. Yes, that's the best fit to actually explain appearance view. So for here we have under beam, we have the opening here. So the opening is not dimension, so I believe the opening should be about, this is 900, let's assume this opening is 1.2. This should be about 1.2 opening, so let's split this here. But let's just split the gap. Go to your modify panel, you see split the gap here, then pick somewhere here, then let's look for 1.2. 1.2 should be here. Okay, so let's delete this. Yeah, let's create a dash line here to show that there's a beam. Let's go to annotate detail line. It's still on demolished, so let's just pick from here, drop it here, then pick from here, then drop it here. Alright, so at the moment, one of the reasons why we don't have a staircase here is this, because our levels did not change. We're having just one level for our floor plan. What we are doing on the next project, we'll be creating levels for different on the same floor. So for now, I think this is looking fairly okay at the moment. So we have all the windows and doors set. So that's it for windows and doors. So the next to be doing is to apply the right dimensions from here. Okay, if you look at your reference material, sorry, I'll be popping this up on the screen so much again because I have a reference material looking at this from here to here is 610. So what you can do is you can click on this window to give you dimension from this place. Let's just change to 610. 610. You can apply your dimensions later on. And for this, we have our dimension set. The dimension marker is somewhere here, so you can just move it and keep it here. 760, so put 760, 760 to move this. So that's for that. Then for this, we have our dimension marker to be 788. Yeah, I think we're having 786 or so. 768. So we're having 788 here, then 748 here. So let's just change this to 788. 788. So this, if you check this now, this should be 748. Yes, 748, you are correct. Alright, so the next thing we're doing is we'll be doing for the this, there are no dimension markers given here, so alright, so but yeah, we have this to be 1,300. Now, so use our line dimension to achieve this. But I just want to do it once so that when we are putting a line dimension, we're just placing it on already measured flow. So this is looking good. Right, for this we're having this place to be about 1,100. So let's change this 1100. So let's leave this to 1,100. So this is 1,750, which is very correct. Alright, so let's delete this dimension now. Alright, so the next thing now is this. We also align it. Just align this. Just put this. I think it's cutting through the wall. Let's just move this manually. Take this and move. Alright, so this one. Just move it. Alright, so this is looking fairly okay. If you apply your dimensions now, you'll notice that the windows are well dimensioned according to the dimension we have here. So the discrepancies we have in because these walls are set here at 150 and not 225, so that's the discrepancies we have here. So let's just continue. That's the discrepancies. These walls are at 150 and not 225. So let's place our dimensions here. Okay. There's another way to actually do this work. I'm trying to bring out all these dimensional ones. I can just come to this modify those dimensions where you have the wall reference. You see this big single reference. You can come in and pick entire wall. You see the option open. I went to option. You put it with wall openings. You pick the entire openings of this wall, but it's set to be at center at the moment. To measuring the center of this, if you say okay and you leave it at center, if you measure the center of this window, but you want it to be at the face of the window, so you go to options. You of the opening, so you go to options and pick this. So all this will be dimension at once. Now you can let's play around this to see how this works. Okay. But this one is measuring from, so let's put it back to the face. This one is measuring from the entire width instead of the internal dimensions, that's why. So it's not actually always accurate, so you have to use individual references because if you are measuring with this kind of tool, you will still have to adjust it. So preferably I use individual reference, which is this. Just pick. It might look stressful, but that's the best way to actually get achieve what you need to do. Achieve without the hassle of coming back again to this game box all over again. So this is like 600. Even if you don't want to save the project, Revit will already remind you that you come far, you need to save the project. So let's try to save the project. So let's keep this here to create more room. Let's just select all this. Then let's have this also. Yeah, let's move. Right. So this is looking fairly okay. If you didn't apply dimensions to the material, this one will be accurate because you don't measure it. So let's pick here and here. Windows were placed exactly where it's supposed to be at the center. So, but on this plan, it's not at the center. So this should be about 1,650 or so. This is 1,650. The second one is 1,150. I'm just using this one. 1,150. So south part of the master bedroom. So let's just pick our dimensions again. Click here, right. So for this, because I'm trying to make this particular window here, but this is 300. Look at the material. I'm working with my reference material device, so this is 300 here. So let's pick this window and change this to 300. Yeah, that's okay. Then pick this window and change it to 290, 295. Alright, so this is fairly okay now. Alright, so I think that is it as it pertains to dimensions. Well, as you know before, these dimensions will be getting in the way of your design. So let's hide these dimensions, select it, hide it, then category. Alright, so the dimensions are there, but they're hidden because we need to do some columns or something here. Alright, so what we'll be doing now is we do our columns and our beams. If you look at your 3D view, there's an easier way of doing your beams. Your 3D view, there should be a beam. The beam should be running from here down to this top area, down to where you have your roof level. That's where your beam should be. But I'll show you how to actually do your beam so that when you're applying your material, it should just be exactly where you kept it to be. So let's create it. You're having a column here and a base here. The column here, so let's make that column. To make your column, you can use your column section, but for the most part of the project, you're actually modeling your columns yourself. Okay, so now we'll be trying to make the columns. So if you look at this particular project, sorry, it's loading. Let's just wait for a while. Okay, this is taking a lot of time. So if you look at this particular project, you can actually load your columns from the main column section. So if you look at this particular columns, it's placed on that edge there. It's placed on the edge. We'll be dropping our column from our natural ground level. So let's try and pick a column from load a column from architecture. Let's just see what it gets. So you go to columns where you have the architectural tree, go to columns, then you would load a column. At the moment, go to load family, then click on load family. You will see the English Imperial browser. Then let's check for our columns. You would go, okay, I think I have okay, yes, that's column. No, this is not sufficient. I'm not checking that one. Let's go to metric. If you can see something, go to the metric library. Okay, yes, this is metric. Okay, well, this is not so sufficient enough. So let's I think we should load from our desktop. I think we have Revit, enough columns in Revit City. So let's go check Revit City for columns. So if you go to your Revit City, you would see columns. So just check for columns and click on columns. Then okay, yes, I think I have enough columns here. But there are some downsides to loading this column family in a project. Because these columns are actually created in older versions of Revit, like 2009 and older versions. Before they convert to your newer version, it might not load your project might not accept that particular column. So that's the downside to it. So let's check on that column. Let's see if this one works. Meta clad column. Let's try this. Okay, let's see. Okay, it's not working. So let's go and do it the way we do it. Let's model a column by ourselves. So let's go to model in place, in component, then let's choose columns. Okay, yes, columns. I think it's okay. Columns are up, but yes, columns. Then let's model a column. So to model our column, we'll use extrusion to model the base of the column. So let me show you something. Let me bring up 3D Painter so you can understand this better. 3D paints. Okay, yes, let's try
just notice something. So if you look closely, we are trying to create our columns, where our columns has a base, then it has sweep, then it has the main column itself. Then okay, this is the base of the column that we are modeling now. This is the base. Then this is the main column itself. This is the main column. Then we have a sweep under. If you look at this, those line, those are called the sweep in Revit. You have something like sweep under, then on top too you have a sweep also. Just you have where the stairs is. You know how our project is. The stairs is somewhere there before the entrance. Let me clean this off. Okay. There we have our stairs. Then we have the other wall. Then the wall continues like that. Okay, we have sweep again up there. That's what we create another sweep for the column. Then that's the beam that the column is supporting. So if we this now we're having our staircase somewhere there. That's the 450 area. We have 3 stairs, so that's about it. So if you look closely at this one, this particular place is where we are creating at the moment. We are creating our beam, our base for our column, rather for the base for our column. So let's create that. In order to create that, let's go to our extrusion tool. In our extrusion, we'll be drawing it on our ground floor level. So let's use the rectangular line work, and let's create an offset of for the base. Let's try 300, so that 300 and each part will be about 600 each. So let's try 300. 300. Yes. All right. So let's create our column. Okay, this is our column of 300 offset each. Let's use our 600, and then it looks big, it looks wide, but let's just see if it works. Okay, this is the base. Then let's create the extrusion end for the column. For the extrusion end, the extrusion end is from this natural ground level to where we have our, let me show you something. From this natural ground level, from this NGL level rather, to where we have our DPC. That's where I think the column should end. So let's use 450. Let's try 450. Now our DPC is 450, so the base of the column, I think it should end 450. So let me show you something. Okay, and click check, and you go to let's just click finish. Now let's go to the ground floor. This is what we've created at the moment. The base of the column, it looks so wide. It looks very, very wide. It's not sitting well in front of the house. It's not in proportion with the house. So I think we'll do something now. It's not even showing on the ground floor level. Okay, let's do something. Let's edit this extrusion again. Let's edit this. It's too wide. Let's make it 500 each. I think let's just clear this off and create another extrusion of offset of 250. So 250 on both ends will be about 500. So let's create an extrusion again. Okay, extrusion of 500 looks okay. Now let's check if it matches. Okay, this looks good. It looks pretty good actually. So let's use this. Then let us. Okay, what we're doing now is let's move this to the center. Let's centralize this. Okay, I think it's okay with what we're having on our material. So let's leave it this way. Let's just leave it this way. For the extrusion, let's make it at 500, because so that we need the column to rise above that 450, because if it were 450 it won't show on the ground floor level. Now it's showing because it is 15mm above ground level, so now it's not showing on the ground floor level. That's why we used 500. So Now look at what we're having. I think it's looking okay. So let's try to create another extrusion. And this extrusion we are doing is the main column itself. It's the main column itself. This one was just created with the base. So we are doing the circular extrusion. Let's set our plane. Then pick a plane. Pick this square you just created. Let's pick that as our plane. Then let's create a circular column, just like what we are having here. This particular column is circular, that one. So let's create a circular column. The problem now is to determine the center of this extrusion. The center of this extrusion, that's what the problem is. If you check well, it's not showing a marker for the center because it's not a wall. Okay, that's not the center. Let's try another place. Okay, that's its midpoint. That's the midpoint. Let's see if we can get the center. It's saying center, but that's not the center. I think we should create a line. Let's create a line to get the center. Okay, that's the midpoint. Let's take it from here. Let's take another midpoint again. Let's take it to that center. Now let's draw the center, the circular extrusion there. Okay, perfect. So let's use 180 will be better because we are having sweep for the remaining parts. So let's delete this straight line. So yes, so I think it looks good. Delete this, then delete this. Alright, good. So the extrusion ends. Let's see something. You know, this our column. The base from the ground floor to that particular level is 500, and from the 500 to where we have the head height of the building is it's supposed to be 3 meters, starting from the ground floor level, but from that head height of that building down to where we have that base of that column is now about 2,950 instead of 3,000, instead of 3 meters, not 2,950 because it's no longer 450 again. The base of the extrusion is now so we're making a beam of 400 above that column. So the height of that column to where we have the base should be 2,550. That's what the extrusion end should be. So let's use 2,550 for the extrusion end. You understand the version? So let's use 2,550. Then create the extrusion end to be 2,550, so that the remainder of the 400 upward will be where the beam would be. The column will be holding a beam somewhere around there. You understand the version? Let's move forward. So moving forward would be, okay, this looks good. Okay, this is it. Well, let's create the sweep before we close this. Let's create the sweep. Go to your natural ground level, then go to create, then let's choose sweep. In order to create your sweep, we'll have to choose a reference plane to create our sweep. Let's set our reference plane. I think it's an extrusion number. Let's pick this. Okay, let's pick OK. Then let's pick line. Let's just pick line. Then let's pick this line. Then pick this line. So it's not showing. So let's check if the visible line is on. Okay, let's off it. Let's try it again. It's not still showing. It's not still showing. Okay, now we've created another line, but it's not still showing. Down. Then let's try again. It's not still showing. Okay, what we can do now is we need to sketch path. I think that's the mistake we are having. We need to sketch it, which I think will show now. Okay, that's it. Showing now. Alright, so what we could do is to go to our 3D. Let's see where it is. Okay, yes, it is where it's supposed to be. Alright, so let us click finish on this. Nice, finish edit mode. Then let's double click on that stuff we see here. Double click. 1, 2. Okay, let's do it from our west elevation, your left hand side. Okay, so let's create our sweep now. Now to create our sweep, we creating that. This is what we are doing on that particular line you see in those fancy lines you see on buildings, on building columns. That's what we are trying to do now. That's what they call sweep. So let's take this one to about, I think this is too thick. Let's use thin lines. Okay, let's see. Let's take this to about how many millimeters? I think 150 is okay. 150. Okay, 150 is okay. Okay, let's now do the remainder part, which is the base of the sweep. This is too thick. This is way too thick. But let's see 50 on this end. Let's use this line to join this. Let's see how it looks. Let's use thin lines. This is too fast. Okay, so let's create an arc. Alright, so I think this arc looks good. Okay, let's see. This is not looking right. So let's move this one outside of it by 20 millimeters. Then let's create another arc here. And pick the arc. Okay, I think this looks good. Alright, so this is what we have. So if you click finish, click finish again. You've created a sweep. Go to your 3D, you see this sweep. Okay, this is the sweep we've created so far. The sweep is not looking too nice. You can always change the material of the sweep to something nicer, like probably a gypsum, white gypsum board or something like that. Something like white will look good with the sweep. Let's use gypsum wallboard. Yes. Okay, gypsum wallboard is actually a white board, something like a white cement board, and I prefer using it because it looks nice and it's have a kind of rough feel to it. So this is what we have. Well, at the moment, the sweep, I don't like the look of this sweep. I don't really like the look of this sweep. It's not looking too nice. If you look at the sweep, it's too plain. It's too, how would I put it? It doesn't look right. So let's see what we can do now. Let's edit the sweep. Edit sweep. Then let us change profile. Then let's go back to the west elevation again. Alright, let's do something now. Let's create more edges for the sweep. So let us move this. Then let's take this backward. Okay. Alright, so let's draw. Let's do this. Just look closely. Watch closely. Let's create a 40. Let's see. 45 looks good. 15 looks okay. 20, then take it up again. Then let's create an arc here. Okay, let's delete this. Okay, this looks better. It has more edges. Let's see how it looks. If you go to your 3D view, okay, let's see how it looks. I think this looks good for me. It looks better than the first one. Okay, this looks way better than the first one. Okay, so now we'll be working on our beam. So let's work on the west part of the beam, which is the left hand side, this part. So what we're doing is, let's go to the west. Let's see. Let's extend this wall. Let's take it back to the roof level. Let's drop it at roof level. The top constraint, let's take it back to the roof level. Then we attach the wall. Then we'll be cutting our beam from this wall. We'll be editing the structure of this wall and creating our beam. in order to create our beam, we did the profile of this wall. What's the profile of a wall? The profile of a wall is the way the wall is built in line work, like how the wall is going to look. If you put it like, for example, this part we are doing now is from that point to that point is where the beam is supposed to run. So let's check the dimension. The dimension of that point should be 400. So let's see if it's 400. From that point to the base or the beam or the column is 400. Perfect. So that's where we'll be creating our column from. We'll be cutting our column from that point. So let us edit the structure of this wall. We go to 3D. Let's see if we can edit it from here. Edit profile. Then okay, it's in realistic. The line will be hidden. So let's go back to our waist elevation. Let's see how it works. So from our waist elevation, we would be creating the base for the ground floor level there. That's where the wall will cover. The wall will still cover that point it's covering before, but the wall will be extending up to form a beam at that top point. So let's create okay, this is at 500. Let's take it back to the ground floor level, which is 450. The ground floor level is somewhere there, so let's take it from that point to the next point. Make sure the line is closing the pink vertical line so that there won't be space in between it. Make sure it's closely looped. So let's create our beam. Our beam is on that point to the other side. So let's stretch the line down to that side. Yes. Then we'll have to split that point. Let's leave it that. Move thin lines. Okay, that's it. Alright, so now we're splitting this other side so that because you can't create a wall like this. The lines are intersecting, so let's split that side. SL, split this side also. Then let's trim trim this to the other side. Yes. Then trim the base of that one to this side. Yes. Then trim this to this. Then trim that to the up one. Yes. Alright, now we've created our beam on our floor. Now the floor that was down there before, it's still down there. It's still going to cover that same place it's covering. That same place that it's covering the first time. You can see now the wall that I've edited has created a new wall as forming a beam up there, and that is still covering the down part. So that's what we just created. So we're doing the same thing for the top one. For the top one, we'll be drawing a wall. Then the top one will be slightly different. The top one will draw a wall, then we'll use the base offsets. So let's go to the wall tool. If you check, we'll create a wall. But I think go to architecture, then let's create a wall that would join this to that. The beam has to follow the wall on the right hand side, the bedroom side. The beam has to follow it. You know that this thing is 300. It's the height from the natural ground level. Look at something. The height from that point to kindly watch closely. This is very vital so that you would understand what's going on. Watch closely. So the heights, let's create the column again. Then I think this has the beam. Then okay, that's the wall. Okay, so you see something now. Just assume this is the window area. So if you look closely, if you go to your south elevation, the front of your building, let me illustrate it with this. If you go to your south elevation, if you measure that top point to this place is 3,000, yeah? Okay, it's 3,000, but from the top of this place to the is 2,600. So our base offset to create that 400 that we see, the 400 from that point to the top of that column, that 2,600, that's our base offset. You understand it? When we draw the wall, we offset it by 2,600 so that we'll be left with 400. So we won't be seeing the. So let's draw a wall. let's draw a wall. Let's pick the wall from, let's follow the, because the beam will have to follow the, you can't draw a beam from that area, but let's see something. We don't know where the other part of that wall is, so let's go check it out in 3D. It doesn't look right. Let's go check it out in 3D. Is that an unconnected out of 8,000? Let's connect it to the roof level first. Connect it to the roof, yes. Then let's go check it in 3D. Alright, so okay, it has not connected. Let's connect it to the roof. Touch it and connect it to the roof. Alright, so now we'll be offsetting this by, okay, you see it's not looking right. It's not looking right, so let's take it from the center of that wall point. Center of that wall point, let's delete this. Let's go back there again. Let's take it from the center of that wall point so that we can attach it to that other one that is there. We don't know where that other one is, but we just assume it's somewhere there. So let's pick somewhere here. Okay, the base range. Let's change the base range and the top range so that we can see what we are doing. The base level should be roof, then the top level. Then it should look down, yes. Base, the underlay, so that we can see where the other beam is. So let's change the underlay of this. If you are looking down, you are seeing it on plan view, but if you are looking up, you'll be seeing what's above. So now you see that one, now that's where the wall is. So the beam, let's extend it, let's see if it touches that now. Fits perfectly. So now those two are actually fits. They actually fit perfectly. So if you go to let's change back what we did. The underlay, change it back to 1. Alright, the base range. Let's go back to our picture. Let's see it. So the wall is cleanly joined. The walls are cleanly joined. So what we'll be doing now is offsetting this particular wall. It's blocking the front entrance, but we don't want that to be, so we'll just be offsetting it to 2,600. I think the base offset, remember that base offset we did that time. So let's change the base offset to 2,600. So it would move up by 2,600, so we'll be left with 400. That 400 that is left there will become our beam area, if you understand what I'm trying to say. The 400 left at that point, from that place to that, from the top range to the down range is 3,000. But when we offset 2,600 from that 3,000, offset means we are taking it up. That the base offset, we are taking it up. There's base offset, there's top offset. Okay, so you can actually offset it up by 2,600. So let's look at what I'm saying. So we are taking this particular one up to that point. So if you use 3,000 minus 2,600, that's our 400. That will give us our beam. So this 2,600 will be where we'll be cutting from. So let's go back there. Select that wall, then offset it by 2,600. Base offset 2600. Alright, see, we formed a beam now. You see how clean it looks. We formed a beam. So now we have our beams we would be working on. If you can, this beam, if you don't want it to be straight like this, but me, I prefer a clean beam this way. But if you don't want it to be straight like this, you can actually edit the profile of this wall. Let's go back to our south elevation. You would see something, edit profile. Okay, then that same thing we did in that other one, but this time you can actually create an arc. If you don't want the beam to be straight, for example, but you want an arc in front of the building, just go to this. Let's create so that the arc won't be sharp. Let's create the first edge. Alright, then create another edge somewhere. Take an arc here, pick that line, then take it to the other line, then it will create an arc for you. Then let's see. Arc is actually slim, but this is just for reference purpose. I prefer using. I want us to use a straight beam. Straight beam looks nicer. So if you split this, SL split, then trim and extend to corner. Trim TR. You don't need to trim actually. The base is just trim the top. You can delete this. Delete this. Okay, let's trim that place to that place. TR, trim this to this. Trim this to this. Since we don't want the wall to cover, there's nothing to cover. The stairs already covering that point, so that's the. So if you go to your 3D, you see the beam we've created. We've created a curved beam, but it looks so slim. But that's the way we can work around that particular kind of beam. Okay, let's see if we can edit the structure of this beam. Go to your south elevation. Okay, your south elevation, yes. Then let's see if we can edit the structure of that beam again. Take it down a bit. Let's see, take it down. Now let's okay. It's not doing the way I need. Okay, let's move this one. Oh, it's wrong. Okay. Let's see what we can do. Let's extend this downwards a bit. This you can just play around it. It's not actually. It depends on what you're trying to achieve. You can actually achieve a curved beam or whatever beam, a zigzag beam or whatever beam you have in mind. It's all in line work. So whatever line work you do, that's the way to creating wall. So let's assume this to be 600. Okay, let's change this to 600. Okay, let's extend to that 400 points. To look awkward, I think, but let's just see how it looks. Okay, that 400. Okay, let's check this. It won't look good because I think it's cutting through that wall too much. Yes, look at it. Let's check in 3D. Not too bad, but I think if this is what you like, you see, you are not limited to what you can do with Revit. If this is what you like, you can achieve something like this. This would have looked fine in the project. Let me get your comments while you are working on this. This would have looked fine if that's what we do. So let's take it back to our straight beam. Let's go back. Okay. We've passed it. Okay, let's just touch and offset it by 2600. Offset, base offset. Let's change it to 2600. Alright, apply. Okay, alright, now so we have our straight beam, which is what I prefer. But if you are feeling creative, you can use the curved beam for yours. You can just use the curved beam if that's what you like. Okay, so let us copy this our sweep to the other side. We're not trying to copy it. Let's edit the sweep. So let's mirror it to that point. You use a mirror, draw mirror axis, then draw a mirror. Just draw a horizontal line that way to mirror that particular distance upwards. So you see what is happening. Then let's take it down a bit. Take it down. But let's use your arrow key. Take it down until it aligns. Alright, you can still use your align too, but let's just take it down like this. Then let's check it in 3D. How it looks. Oh, okay, yes, we've created our sweep again, but We need to move it inward a bit. Let's move the column inward a bit. So let's move it inward. It looks a little bit offsetted to that side, so let's move it inward. Go to your ground floor level and let's move it inwards a bit. Okay, let's check it back. Okay, it looks good. Personally, it looks good. It looks okay, I think. Yes, I think we're good with this. This is actually good. Okay, I think this is looking very good now. So for the next thing, we'll be doing this is the roof level. We'll be doing the other part, the terrace area. Let's do the columns in that terrace area. We'll be repeating the same process. If the columns were equal, the columns are a little bit smaller than the first one. If the columns were the same thing, they'll just copy this and go and drop at that terrace area. But I think the terrace columns are smaller, slightly smaller than that one. Dimensions are not given for the columns, but let's just think it's about 400 millimeter wide on each side. So let's go to the terrace and let's create something. Okay, we'll be doing the same thing. What we did, let's hide our dimensions, hide all our dimensions, hide dimensions then. Okay, now you can work very well. Okay, let's see. Okay, so we're creating our columns somewhere there. Go to architecture, components, model in place, columns. Okay, column 2, I think, is it 2? Yes, column 2. Let's continue. Okay, let's move forward very fast. Okay, let's create another extrusion. Then let's use the offset of, we are creating this particular, so about 200, I think. Let's use 200. 200 looks good. Okay, then let's create our extrusion. Let's see where it is. I think yes, it's center. Okay. Alright, so I think this is it. Okay, it looks good. Yes, it looks good. So let's click the extrusion end, just like the first one, to be 500. Extrusion start 0, extrusion end 500. Okay, if you click on 2550, you know the column of view was 2550. That's why it's like that. But we want this particular behind the base of the extrusion to be 500. So let's clear this. If you put 3000 to go up too much, so let's change it back to the use 450. If you use 450, you know it will show here, but if you go to your ground floor view, you won't see this particular column. It won't show on your ground floor view. See something? Go to your ground floor view. Because we used 450, it is there, but it's not showing on your ground floor view. But we need the base of the column to be slightly above 450 so that it will show on that ground floor view. So let's change that particular column back to 500 instead of 450. Then if you would see it now on your ground floor view, once you click apply, you click OK, see the column showing on ground floor view. Okay, so that's the column showing on ground. Sorry, the dimensions are actually hiding that's why we need to hide dimensions. Let's just hide this category, hide and view category. Okay, let's hide everything. Now you see the columns you just created. The base of that column now is showing on your ground floor view. If we didn't push it up a bit by 50 millimeters, which is a 500 millimeter from the natural ground level, it won't show on your ground floor view. So that's the difference. Please, just in case you have any questions, kindly just drop a comment and we'll respond immediately. So let's create the main column itself. So let's create a circular column just the way we have. Let's pick a plane. Okay, let's pick the top. Yes. Alright, let's create a circular column, But just like this one, we won't be able to get the center of this. You won't be able to get the center of this. We want that column to you can correct, because we pick a plane. You can try draw your column from here. You can draw your column from here. You can draw your sweep from here, because you've picked that particular surface. That's where the thing will be drawn on. So, for example, you see, because we picked that particular surface, we are drawing it now on 3D. That's if you prefer working on 3D. Some people prefer working on 3D. I don't really like working much on 3D, especially if I'm drawing simple geometries like this. Wherever you place that thing, it's going to be on level. It's going to be on 500. That's it. That's what it means by setting a work plane. When you set your work plane, anywhere you put that particular thing, if you put it here, if you put it on the step, wherever you put it, it's not going to draw it anywhere but on 500. That same work plane of 500. That's what you mean by set a plane. So let us draw. Okay, you see, it's not actually centered to that point. So let us create another one. Let's see how it is. Let's create this. Check the center of that. There's the midpoint. Midpoint. Yeah. Okay, take it to that side. Another midpoint again. Take it to that side. Now we have the center. Now let's create our circle in the center. This one is 200, so it will be less than 200. Let's make it about 180 is too much. Let's take it down a bit. 180 feels too much. 160. Alright, so let's use 160. Let's delete this, delete that. Alright, so let's click 150 here. Okay, 150 looks good. Okay, let's click finish edit mode. Then let's the extrusion end. As just before, that same one we did. The extrusion end. Let's go to your extrusion end for this one. Remember it was about 2006. It was extrusion end is from that point to that top point. From this point, from that 500 to that top point. So let's do the mathematics. If you go check from that place where you have your base of your column is 500. Yeah, from that place from 3000, the top of this place is 3000. The top to that point, but now top to the bottom is 3450. But we have our base of our column 500. Now from that base of that column is 2950. Then we have 400 beam. The beam is 400. That's minus 400. 400. Okay. 400. Then whatever is left is what is the extrusion end 2550. So if you don't understand what's just going on, just leave a comment so I'll explain better for you. So let's change the extrusion end to 2550. Now it will go up by 2550. I think this is perfect. This is okay. Okay, now so if you go to the ground floor level, you see we need to shift this a bit. Let's shift this. Let's create our sweep. Let's create our sweep. To create our sweep, with sketch path, I pick a plane. Okay, yeah. Yes. Okay, let's see where it is. Is this set? Yes, it is where it's supposed to be. Alright, yes, it is there. Okay, then we click on this one to take it to where it needs to be. Okay. Yes, I think we can draw it from this view. Let's see if you can draw it from this view. Make sure the edges are sharp edge. Like if you are using left elevation or right elevation, make sure it's a sharp edge. You can actually use your elevation view if you're not using your 3D view, but let me work on it on 3D. Thin lines, let's use thin lines. So that if your lines are too fat and you're not seeing what you're doing, use thin lines. Then let's take it to, let's all do something simple, just like we did in the first one. So take it up by 20. Let's get the height, total height of the sweep first. Let me see. I think 150 will be okay again. No? Yeah, I think 150, 120. Yeah. let's see which one will be okay. It just depends on the proportion of the columns that you use in determining your sweep. If your columns are longer, your sweep should also be at least a bit long, so that it would be in proportion with the column itself. It won't be looking too flat and small. So let's just do something simple and fast. I still hope you still understand how to create sweep. Just the way you created floors, you use sweep in creating floors and creating stairs. It's the same thing we are doing here. We are using sweep to create columns and all that. So that's what you use sweep for. So let us use an arc tool to get this point. Delete this thing. Let's use an arc tool. Arc, yes. Then pick this so that we can get all those extra curves that you see in columns. Oh, this is not looking. Let's move. We have to move that upper one a bit. This is too. It came out too much. So let's move this inside a bit. Let's change this to 10 or so. Yeah. So let's use an arc tool. Yes, arc. Okay. So yes. All right. This is good. This is really good. Okay, this is looking okay. Finish edit mode. Click check, then click check again. Then let's see what we've created now. We've created something okay. Okay, let's pan this. Let's see how it is. So far so good. This is looking good. So let's do the same thing. Let's mirror it up there. Just mirror, taking it up. Let's use the draw mirror axis. This is the peak, because you don't have the center of that place. There's nothing to place as your center. That's the difference between peak and mirror. But for draw mirror axis, there's something to. There you just draw and you create. Sorry. Okay, this work plane is too sharp. Let's go to another view. Okay. Let's use this view. This view looks good. So let's draw mirror axis. Then draw a horizontal line. Anywhere, then you correct it later. If it doesn't align well, you take it up. Then what you can do now is let's just align instead of pushing it up. Align this to this. So you can also lock it. If you lock it now, even if you move, whatever you do is locked to that place. So that's the difference. So instead of pushing it up, you can also align to that particular view. So yes, now we've created our column cleanly. This is the way I prefer creating columns, because if you are using your natural column if you are using the column created in your Revit or Revit City, or the column you have in your metric library, it's limited because it's not going to give you the design you want. At the same time, sometimes you might have the hassle of not able to load in your project, which is something that I encounter most of the time. So let's get the center of. You can't determine the center of this, but let's keep it here. Then let's draw another line and keep it here. You know your beam can't be on your window, so the thing will complain. So we'll have to move that window. Escape, and let's move this inward a bit. Then I think that window should move. That window needs to move. Let's move the window. Okay. Let's move the window. I think it's looking okay. Go to your 3D view. Okay, this is what we have now. Since we have the base, unlike the first one, we could have drawn from the ground and attach it to up. But since we didn't edit profile, you can actually take from this place and edit profile. But let's use base offset instead. Since we drew a new wall, we are using base offset. So for this, let's use the base offset. The main one is 3000, then we'll be removing 2600, removing 400 from it, which is 2600. Yes. So So that will be the base offset. Let's change the base offset to 2600. Okay, apply. And you have your beam sharp. This is looking very good. Alright, let's do the second one. 2600. 260. Okay, let's apply. Alright, I think we have our column is slightly not in place. So we'll have to adjust that. Our column is not looking good where it is, so let's move it in a bit. Yes, move it in a bit. I think this is looking good. I think I'm very satisfied with the way it looks at the moment. Sorry it took this long to create all this, but you need to understand this concept of this particular creation, in this particular way of creating columns and beams, because in Revit you'll be making use of sweep a lot. Especially if you are modeling your design from scratch up, you'll be using sweep a lot. So that's just it. Let's move this. This window is correct. I think this needs to go down. Let's change this to 900. Instead of changing it also, you can also align that window to this window. 900. Okay, now it has aligned. The reason why I'm checking all this is so we would know if all the windows, what's the final check. We are checking the fenestrations of the window. Okay, if you look at this one at the bedroom, the toilet windows are not looking okay. So the toilet windows are not looking okay. Okay, so let's work on our concrete facial. So in order to do your concrete facial, you can actually choose a design you've seen online. If you like something you've seen online, you just choose from a particular concrete facial you've seen online. Let me try to connect the internet. Let's see if you can get a nice looking concrete facial online. So you can always explore the internet, explore online to see if there are better looking concrete facials other than the one you have in mind. Because I have a particular one in mind, but I'm saying, let me check if I would see something really good for this project. It's connected. Let's go to the internet and check for concrete facial. The concrete facial designs. Okay, let's see. Okay, we have some concrete facials here. Let's see the one that looks good. Let's see the one that looks okay. Let's check. Oops, I think I have down internet. My internet is down, so the internet is down. So let's change to. Let's just create a profile. And I think I have a profile in mind. Let's just see if we can work down. Let's create a profile. Let's go to your roof plan. You go to your roof plan. Now you have all the outline of your building. So the top of your building, everything is outlined. See where the beam is. Everything has formed a ball looking shape up there. So let's go to create another sweep. For your profile, you'll be using sweep to create your profiles. So let's go to generic profile, but generic model rather. Then click OK. Then let's create our sweep. We are creating our sweep around all these portions of the beam. So we're using pick lines. Let's use sweep. Then sketch path. Then let's use pick lines. Faster. It's faster and faster. Okay, use pick lines. Alright. Once you use pick lines, you'll be picking all the external wall area. You pick this one, first one, pick, then pick, then pick. Don't mind if it's affecting, we'll trim it later. Okay, then let's pick this part. Pick. Mind you, why is this slim like this? Because thin line is turned on. Let's work. You can turn it off so you can see it very well. So let's continue. Pick. Here. Alright. Pick here. Okay. So now let's trim, because Revit will never allow you to create a sweep like this. So let's trim all the edges. Trim and TR. Trim this to this. Trim this to this. Then let's trim this to this. Alright. So let's trim that to this, then trim this to that. Alright. So let's click finish. Alright, so let's double click on this part. 1, 2, just twice. 1, 2. Then let's use you can use our north or your south. Your north is your behind your house, the south is in front. So let's choose a particular view. Let's choose south, the front. So open view to take you to that place. Then let's create our sweep, the concrete fascia. Creating our concrete fascia now. So let's just create the height of the concrete fascia should be around 300, I think. 300 looks nice. 300 would look nice. Then let's create the length should be there about 300 also. Let's see the length. 240. That's where you can actually you can determine the length and the width of your sweep. It depends on what you're trying to achieve. So I'm thinking of something in mind. I have something in mind. So let's see. Let's use 300. Okay, let's see. Let's create the edge, the way the sweep is supposed to be. Let's create a form. Let's create a form with it. Something that looks nice. Use thin line so you can see everything well. Create a form. Then 80. Just create something that is 50. Then create another form. 80. I think 80 looks nice. Okay. You just 80 then. Okay, this looks nice. 80 again. 80 again. 80, I think. 80. Then let's use 80 again. Yes. Then let's do this. So we'll be using Arc tool to create those curved edges you see on concrete fascias. I think that's what we're doing. We create Arc tool. Then what you can do also is you can also use your you can also use line tool to create a curved edge. Let's just fillet arc just to create something unique. So let's try this again. Fillet arc. You can just play around the concrete fascia. It's not rigid. You don't have to do it exactly the way I'm doing it. You can just play around it. You can use the one you like. You can make it fatter, rounder, whatever you want. Let's do this to this. Okay, I think we have a round curved area there. Yes, this is looking nice. So I think this is okay. Let's move this. I think this is looking sharp. This is looking good. Okay, now we've created our concrete fascia. Now let's see how it looks on 3D. Remember, the concrete fascia is the base where your roof will be sitting. Although the level you created a particular level called roof level, but now we have our concrete fascia. They are supposed to be sitting on that roof level because we are not using fascia boards. Fascia boards are actually old school, so we are actually using concrete fascia. Let's align this window. This window does not look nice. These toilet windows, the windows I just remembered now. Let's align it to that particular video so that there will be good fenestration for the building. AL align. Let's see if we can pick this. AL align. It's not allowing us pick. I think this view is not looking good. Let's try it again. Okay, it's not allowing us. Let's pick. Okay. it's not allowing us to pick this, so we can't pick any of this in this view. I think because it's a 3D view, it's a sharp view, it's a perspective view. So let's go to the east elevation. Yes, the right hand side. Yes. Then I think it will allow us now. Let's align AL. Alright, now you can align it. You can always lock it if you want, but let's just leave it like this. So now it has aligned properly. So there's a window behind this window. Let's delete this. Okay, no, you deleted the wrong one. There are two windows there. There were two windows there. Let's delete one. I think delete this. Alright, so this is looking good. It has aligned properly. Now there's good fenestration in this building. So let's go back to our 3D view and see something. Alright, so what we're doing now is to create our roof. I'm very sure all of you already know how to create roof. Since you've studied the material I gave you guys on roof, you should have been able to create roof on your own. Okay, this one is different. Align this to this. That's just like the finishing touches. Remember, this is 3D view. Let's go back to a view we can work with. Okay, west, yes. Then you make sure all your doors all your windows have good fenestrations. They are at equal seal heights. All of them are at equal seal height. That's just one of the finishing touches, so that when you are putting it on sheets, all your views, all your windows and everything will be aligned properly. So let's create our roof plan. Our roof. For this, our roof is supposed to sit on that plane, the plane selected. Now that's where our roof is supposed to be, but now our concrete fascia is now on that particular plane. So when we draw our roof would be on that plane, but we can always move it up to where we have our concrete fascia. So the concrete fascia is sitting where the roof is supposed to sit. The concrete fascia is about 300mm high. If you remember, from the concrete fascia to the natural ground level, which is your NGA, your zero ground level, is 3750. As a 3750, remember the entire level is supposed to be 3450, but we have extra 300 for your concrete fascia, which is the height of the concrete fascia. Now it has bumped the level of the roof to 3750. So 300 plus 3450 is 3750. That's how we got this 3750 from here. So what we're doing now, we can actually create our roof. Your roof will be staying on this plane. Let's move this in a bit. Okay, so your roof will be on this level plane. When you draw your roof will be stopping there. That place you have level 3 roof 3, like 3 roof level. That's where your roof will stop, but we'll be creating an offset of 300 for the roof. I'll show you what we mean. So let's just create our roof. Go to architecture, then go to roof. Then look at the kind of roof that is provided for. It's a 400mm roof. It's too thick. It's too thick. Let's check if you have something slimmer. There's none slimmer. There's nothing slimmer there. We're creating our roof. Let's go to edit type. 125 looks slim. It looks okay. 125 looks okay, I think. But let's just edit type. Let's make it smaller than that. We need something slimmer. Let's see. Let's try 100mm is okay. Let's rename this to 100mm. Okay, so I think everything is good. Apply. Okay, let's create our roof. Then pick lines. Sorry. And let's pick the entire face of the sweep we created. As you are picking the lines, it will be creating the 4 path for you. All those things you see like triangle are the 4 path of the roof. If you have done your assignment of roof, you would have understood what this is. So kindly just go back to the reference material on roof and watch closely how roof are done. So now we've created all the parts and all the edges. Let's finish this. You can always, it's showing like a cut plane. So let's go to the 3D view. You can change the view range. If I increase the base of, let me show you something. If I go, at the moment the roof is at the plane it's supposed to be. The roof is downwards. It's going downwards by 300 millimeter, but we want to attach that roof to where our sweep is, because now it's not looking right. Our sweep has taken the place where the roof is supposed to be. So all we can do is change the base offset to about 300 millimeter. Now our roof will go up to where that sweep is. So now if you look at it, it has gone up. So now at the moment we have our building to be half complete. So this is looking fairly okay at the moment. So let's check realistic view. Okay, this is what we have. This is what we've been able to create. So, okay, this is looking fairly good. Let's see if there's any discrepancies for the fenestrations. Okay, let's move that wall outside. Remember those walls we have outside, let's just move them. I think that's where the sockaway is supposed to be. Yes, let's see. Okay, the reason why these dimensions are not showing huge, as I'm trying to do it, is hiding. Why? Is because with hidden anything dimension, you can't apply anything dimension to this work again, because the dimensions have been hidden in category. Whatever dimensions is coming again in this particular work, it will not show because we've hidden the dimensions in category. So if you can unhide it, you'll be able to see the dimensions we've created again. So all you can do is press escape, click on one, then on hide category, and you'll be able to unhide the rest afterwards. So you could just see, just play around this thing yourself. It's actually fun. So let's move all this out of the way. Let's move all this out of the way. Okay, alright. Now we have that dimension we created. Let's delete this first. Okay, that's the dimension we created. It had been hiding all this while. So you can change dimension. Let's use 500, I think. 500 looks fine. 500 looks okay, I think. For the length of that this thing, let's use 500. Okay. On hide category, just hide the rest back. Okay, let's move on. Align this to be this thing. Let's create the last one. Align to this. Go to your architecture, your modify panel. Then go to join geometry. Join these two to this here to create a good clean wall for you. Then let's see what we've created so far in your east elevation. Okay, this is what we have. I think the reason why they have something like that in this particular project, maybe that's where the sockaway will be. So I think so. Let's delete all these dimensions. Alright, so that's it for this. For our next class, we'll be applying materials to this particular project.